All right, we're in section 2.8. So we're going to talk about quadratic models today. So the first thing I need to do, I need to grab some data. 2.8, yes. Data. The correct way.
Is that the correct way though?
Why is it?
I mean, like, I don't know. Data just sounds crazy. It's like, okay, Mr. Beaver. So, like, you brush your teeth, right? You put the toothpaste on first, and then you like get your toothpaste. Then you put the toothpaste on.
Wet first, then toothpaste. No.
You guys think I did again, and then that's what I do. I'm just curious.
All right. So, I'm going to leave this table up here. You're going to need to copy it down for the example that we're going to do. So let me. So what we have here is a set of data that describes. We did an experiment, and we have the speed that our car is going in miles per hour, and the mileage that we get in miles per gallon. So we drive our car at a certain speed, and we see what our mileage is. So this data represents that information. And what we want to do is construct a model for this data and use the model to decide what speed gives us the highest mileage. Not based on what we measure. We want to construct a model and use the model to give us that information. So this is the set of data that we're going to use. So I'll give you a second to write that down. Let me get my calculator here. There we go. All right. And once you have that written down, I'm going to start because it's probably going to take me longer than you. We're going to put this information into our calculator. And to put it in our calculator, we're hitting the Stat button. And we want to edit, so I'm going to hit Enter. Put the X's in list 1 and the Y's in list 2. Whoops. It did that before, too. All right, so there's my X list, and I'll put the Y's in list 2. All right, so we have our x data in list 1, y data in list 2. Everybody good there? All right, so we want to plot this data to get an idea of what kind of model that we're going to construct. So to plot the data, we're going to go to the second y equals. It says stat plot above the y equals button. So second stat plot. And we're going to turn one of those on. So I'm in stat plot 1 here. Just hit enter. And my cursor is flashing over on. Hit enter. So my stat plot is on. This says my x's are coming from list 1, my y's are coming from list 2. It's going to put a little square for each point. To get the calculator to graph these, so your window is nice, I'm going to do zoom, and then zoom 9, I believe, is zoom stat, and then it sets the window so that it's for your data. Zoom stat. There's those data points plotted. So if we connected this with a nice curve, what is it going to look like? Looks like a parabola. So we think that maybe a quadratic function is going to model this data. So let's get the calculator to give us a quadratic function that models this data. So I'm going to go back to stat again. And this time I'm going to calculate. Going to go over to calculate. And in calculate, there are a lot of options. These are if you want to find averages and standard deviations and stuff. But we have all these. This REG stands for regression. That just means a model for the data. We can have a linear regression, AX plus B. The quadratic regression is the one that we're going to use. We could do a cubic regression, a third-degree polynomial, a quartic regression, fourth-degree polynomial. I'm just going to scroll down to talk about some more of these because not all of your data is going to be a quadratic. The different type of linear regression, logarithmic regression, that's what ln means, exponential regression, so like exponential growth or decay or something like that, power regression, logistic regression, sine regression we talked about in chapter 4. We modeled some data with a sine curve, sine regression. But let's go back up and do a quadratic regression. You do stat, and then you just arrow over to calculate. So we're going to do a quadratic regression. Depending on which model of the calculator you have, your screen might look a little different, but it's going to be essentially the same. I'm going to hit enter. My list, X list is list 1, my Y list is list 2. The other stuff we don't need to worry about. So I'm just going to hit enter. I always forget how to store the regression equation and what to do with that. So if I told you, then you would just get confused. So I'm just going to write it down. Calculate, enter. There's my quadratic regression. AX squared plus BX plus C. And it tells us that A is negative 0.012 about. B is 0.945. And C is about 12.34. So I'm just going to write those down. A equals negative 0.012. B equals, let me get my calculator again, 0.945. And C equals 12.34 about. So my model that the calculator comes up with is negative 0.012x squared plus 0.945x plus 12.34. And at this point, we're very thankful that our calculator can do this, because to do it by hand is very, 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 very tedious. All right, so now I'm going to go into my calculator and plug this equation in to the y equals. So there's my calculator. I'm I'm going to go here to y equals, and I'm going to put that in there. And make sure you put 0.012, otherwise it won't come out correct. X squared plus 0.945x plus 12.34. And now I'm going to graph that, and it should show up right on top of my data. And there's a nice parabola that models that data. And notice that up here at the top, so in this area, that the model that we came up with doesn't quite fit the points as well as it does for these other data points. So what we want to do now is get the calculator to tell us what speed gives us the maximum mileage, based on not on this data that we collected, but on the model that we came up with. And it looks like it should be somewhere in here where we get the maximum mileage. So we're going to let the calculator find that maximum. I'm going to do second trace, so this calculate. And one of your options is maximum. And it asks you for a left bound. So that means put this little flashing cursor a little bit to the left of what it seems like is at the very top. And hit enter. Then it asks for a right bound. So you put that little flashing cursor a little bit to the right of what seems like the very top. Hit enter. And then a guess. So you put the cursor right where you think is about the top. Hit enter. And it says the maximum is at 39.4 miles per hour, and the highest mileage is 30.9 miles per gallon. Now we measured some that were higher, but that's also where our model doesn't fit the data quite as well. So this is, the model says if these points follow the model, this would be my maximum mileage at about 39.4 miles per hour. My maximum mileage would be about 30.9.
Well, I mentioned the first 2 points. Can you scroll up?
So this says the max is at 39.4 miles per hour, and we get 30.9 mpg. Whoops. Based on our model. So the homework this evening is just doing these various regression models. Some of your calculators will give you an R and an R squared value. You don't have to worry about those. I think one of the problems in one of the parts it asks you for a correlation coefficient or something like that. Don't worry about that. Just answer the questions that have to do with using the model to find particular piece of information. If you want to graph something other than your data points, you need to go back into your stat plot, your second y equals, and turn the stat plots off. Otherwise, anytime you graph, those data points will show up. If you want to clear out your list, I'm going to go to Stat and to Edit. To clear out this entire list, just arrow up here at the very top, hit Clear, and then arrow back down. And it clears the whole thing out.
Favorite?
Yeah?
How do you put a line in it? was there from other stuff, but
So you have to do your model. So you do stat calculate.
oh, okay, I got it.
Okay. Mm-hmm. You know how to who what?